Apparently mine doesn't, because this should say triangle ABC compared to triangle XYZ. So we're going to look at how these things compare. So if we look at length of, and I'm kind of upset that it doesn't come through, I'm going to put triangles in there because that irritates me that it doesn't. So the length, what they mean by length is, what I'm actually talking about is the base. I'm talking about the bases. The base of triangle ABC. So the base of ABC equals 20. And the base of XYZ is going to be 16. Which that ratio, if I simplify, would be 10 over 8, which would be 5 over 4. Now I want to stop really quick. How does ABC compare to XYZ? Are they congruent? Are those two triangles congruent? Meaning they have the same base, the same height, everything. No, they're not. You shouldn't be shaking your head up and down. Oh, okay. Oh, okay. Let's be thinking about this. Are these two triangles congruent? No, they aren't. What are they? How do they compare to each other? If they're not congruent and they have the exact same angles, yeah, they are similar. So in order for any of this to work, our triangles need to be similar. So I'm going to state that right off the bat. I'm going to say, guess what? ABC is similar to triangle XYZ. And we could have figured that out between the ratios. So I could do 20 divided by 16, make sure it equals 15 over 12. But I'm going to tell you right now that those two things are similar. All right, so those two triangles are similar. And their bases have the ratio of 5 to 4. What about their heights? Would that still have the ratio of 5 to 4? Because their heights would be 15 over 12, so it's also a ratio of 5 to 4. In fact, every one of their parts, that's what it means to be similar, is that every part's going to have the same ratio. So if I figured out the length of AB, we would know the length of XY because it has to have that ratio of 5 to 4. Let's see how that relates to area. Let's see how that relates to area. So triangle ABC and XYZ. Well, the area of triangle ABC is going to be half our base, which is 20, that's a 2, times our height, which is 15. And the area of XYZ is going to be half its base, which is 16, times its height, which is 12. Let me work through the math real quick. If you just plug that in your calculator, you come up with 150 over 96, which we're going to be able to reduce down to 25 over 16. I'm going to do something else with that. How does 5 relate to 25? Yeah. Okay, so 5 squared equals 25. What does 4 have to do with 16? Chris? So it's 4 squared as well. So if we note, if I know the scale factor, or our ratio between sides is 5 to 4, the ratio between area is going to be 5 squared over 4 squared. Okay, so it's key to know the scale factor because then I know my scale factor of my area. All right, let's do volume really quick. So volume is going to equal area of that triangle times that depth. Okay, so we already know the area of triangle ABC is 150. And we're going to multiply that by its depth of 10. And the area of triangle XYZ we said was 96. and its depth is 8. When I multiply this out, whoa, weird. We have 1,500 over 768. For the sake of things, that reduces down to 125 over 64, which is going to be 5 cubed over 4 cubed. So we start with scale factor. If we square the numerator and denominator, we have the area ratio. If I cube it, we have the volume. We don't have to worry too much about the volume for this one. We're more concerned about this, but our next unit is going to be on volume, so it'll be good to know for the future. All right, so let's put that into some facts. If I have two polygons that are similar, so this not only works for triangles, it works for any polygon that is similar. If I have two polygons that are similar, the ratio of side lengths is called our scale factor, and that's going to be A, for this example, is A over B. Now picture this with me, because we kind of have to go on a ride. Every single side follows that it's A over B. This would be the ratio A over B. This would be the ratio of A over B. This would be the ratio of A over B. So since every single side follows that pattern that it's A over B, even our perimeter is going to have the ratio A over B. So if our scale factor, in other words our side lengths, if our scale factor is A over B, our perimeter has the ratio A over B as well. The area is going to be A squared over B squared. And finally, our volume is going to be A cubed over B cubed. But like I said, we're more concerned about the perimeter, the sides, and the areas, not so much on the volumes. Okay? That's kind of like an offshoot, just so we can see it. So we need a scale factor. That talks about the sides. That gets you my area. All right, let's look at our first example. It says triangle ham is similar. They have to be similar to use this. All right, tomorrow we're going to talk about their methods. They have to be similar. So triangle ham is similar to triangle rib, where AM equals 16. I'm going to draw my triangles really quick. Doesn't matter how accurate I am. We're just going to call one ham. And that's similar somehow to rib. So I'll make rib a little bit smaller. I don't know that it is. All right, those two things are similar. So the area of ham over the area of rib. Well, I know ham is 96 square centimeters because they gave me that fact. So we have 96 over rib is 54. I don't want to deal with 96 over 54 because I know for a fact at least 2 goes into it. Can someone simplify that for me? I know at least 2 goes in it. Anyone get it? Yeah.
6 over 9. So it's 16 over 9.
It becomes 16 over 9. So that is my ratio between areas. But remember that the ratio of areas is actually A squared over B squared. So in order to get my scale factor, so my scale factor, maybe I'll put it right here, my scale factor, we're going to take the square root of 16 over the square root of 9, which is going to be 4 over 3. The other way we can look at that is this is actually 4 squared and 3 squared. So my scale factor is always when I take the square root of the numerator and the denominator. All right, the next thing is I need to find B or IB, knowing that AM equals 16. So I'm going to note to myself that ham is on top of rib on our original ratio. So I need ham on top of rib when I'm finding AB. So my ham, which is the AM, is going to go on top. So that's from my ham one. That's why I put it on top. And it's going to go over my rib one, which is IB. And that's going to equal our scale factor of 4 over 3. Now we just cross multiply to solve. So we're going to have 4 times IB is going to equal 3 times 10 is 30. 3 times 6 is going to be 18, so it's going to be 48. Divide both sides by 4, and you're going to have IB equals 12. These are tough problems to picture. It might seem easy if I'm doing it, but you really need to pay attention to understand what's happening. All right, if I'm given the areas, we use that to get to my scale factor, which gets us to our sides. If I'm given 2 sides, I'm going to use that to get to my scale factor. I'm going to use that to get to my area. All right, but that scale factor, that's the guy that connects everything. All right, so this is the most important part. So you have to figure out, if they give you area, how do I get my scale factor? If I'm given sides, how do I get to my scale factor? Okay, so that scale factor is the most important part of both of them. In fact, if you get to your scale factor, you're probably going to have almost all your points on the test on these problems, right? Because once you have the scale factor, everything else should fall in place. All right, let's keep going. All right, triangle CAT is similar to MSE. Like I said, they have to be similar, with ME equaling 6 centimeters and CT equaling 12. If the area of CAT is 72 centimeters, what is the area of MSE? So this time I'm working with sides. We had sides, so I'm going to go ahead and draw these two things. I'm going to draw CAT. And that's similar to my MSE. And CT is 12. ME is 6. All right, we're dealing with ratios, right? And we have to be concerned about what goes on top and what goes on bottom. So I'm going to go ahead and label these real quick. Remember how we used to when we dealt with ratios? I'm going to call this guy top. I'm going to call this guy bottom so I don't make any mistakes. If you worked ahead and you put this on top and that on bottom, we're still going to have the exact same answer. Okay, so I'm going to say MSE is my top and my CAT is the bottom. So my scale factor, which is always the guy I'm looking for, is just our sides compared. So that's going to be 6 over 12, which equals 1 over 2. So my scale factor is 1/2. All right, then if I deal with my area, they gave me that CAT is 72 centimeters. Well, CAT is my bottom. CAT is my bottom, so 72 is going to go on the bottom. And that has to equal something is horribly wrong there. Something is completely wrong there. Even if I put triangle, even if I put fact up here, something is horribly wrong right there and I can't do it. Yeah.
You have to do the square of 1 and 2.
Remember that the area is a squared over b squared. So if my scale factor is 1/2, and this isn't really a word, but I'm going to call it my area factor, is going to be 1 squared over 2 squared, which equals 1 over 4. So that means instead of 1/2, this has to be 1 over 4. Those that didn't see it at first, do you see it now? All right, we have to remember that. And even though this isn't a word, it's a good thing to know that you have a scale factor and you have an area factor. All right, it's a good thing to know. And you have a volume factor. It's a good thing to remember. All right, then we just have to use cross multiplication. Well, 4 times the area of triangle MSE is going to equal 72 times 1. So the area of MSE is going to, why do I feel like I made a mistake? I did not make a mistake. Yep, it's 18. For some reason I thought it was wrong. But it's correct, it's 18. Did anyone work ahead and flip? Did it still work out to the same answer? Yep. So she worked a little bit ahead, and she had this as her top and this as her bottom. And it came out, as long as you stick with it being the top and the bottom, you're going to be okay. So as soon as they give you 2 triangles, just like we did before, pick one to be your top and one to be your bottom. Sometimes they'll pick it for you. Like this one, I'm going to go ahead and pick rect is similar to angle. So if the ratio of their areas is 9 to 16, if they give it in this order, it's generally assumed that this is my rect and this is my angle. Okay, I'm going to put this in on the next slide though. All right, so it says rect is similar to angle. If the ratio of the areas is 9 over 16, so I'm going to note that. I'm going to note that they're implying that rect is on top because they put it up first, and that angle is the bottom one. Well, I should have left that one capital as well. So that means rect is my top, and the other one is my bottom. All right, it's always good to get that out of the way. Then you don't have to worry about making mistakes. Then the scale factor, so if the ratio of the areas is 9 over 16, can someone give me the scale factor then? If the ratio of their areas, yeah, Mary, it's going to be 3 over 4. And that came from the fact that we do the square root of 9 over the square root of 16. What's the ratio of the perimeter? Alec, do you know the ratio of the perimeter?
Is it the same? Or?
Yeah,
Okay.
it's the exact same.
So 3 over 4.
It's going to be 3 over 4, yeah. The only time it changes is when I start talking about areas or I start talking about volumes. Yeah, so my perimeter, all my sides are going to be the ratio of 3 to 4, so is my perimeter. If LA equals 24, then what is the length of TR? Let's go ahead and draw these pictures really quick to see what. So typically if I have 4 sides, I kind of draw a rectangle, even though we don't know what it is. CT and my other one, we'll say it's similar, it's just smaller, is A and GL, because order matters, right? As soon as I label this one, R has to go with A, E has to go with N, C has to go with G, and T has to go with L. All right, these are similar. They tell me that the length of LA is 24. I'm looking for this length. Well, rect is on top, so that missing side, let's go ahead and call it X. So I'm not putting a question mark everywhere. We're going to call that X. So that means X over 24 has to equal the scale factor of 3 over 24. Yep. I just kind of transposed it for some reason. All right, so rewriting this, we can use cross multiplication. 4x equals 72, so x equals 18 once again. Did you get it?
Mhm.
Good. I assume that's the dropping of the mic/pen. All right. We just got a couple more to go through. We'll hurry up. All right, it says use two figures are similar using the areas. Find the scale factor of the small to large figure, then solve for x. So small to large tells me that this is going to be my top. This is going to be my bottom. My scale factor is just going to be my small side, which is x over 6. Well, does that give me my scale factor? No. Okay. Let's go somewhere else. Let's go with do we know the areas of both of them? So let's go with just the area scale. All right, we'll go with the area scaling. So that'd be 50 over 72. What does 50 over 72 simplify to? That's just 25 over 36. Yeah. Oh, that's what I guessed. 25 over 36. So my scale factor is going to be the square root of 25 over the square root of 36, which is 5 over 6. In other words, let me go ahead and slide this over. This equals 5 squared over 6 squared, and that's for the 5 over 6. So my scale is 5 over 6. Let's go ahead and solve for x. So that's going to be x over 6 has to equal 5 over 6. Do I have to use cross multiplication here? Sam, what does x have to be without doing cross multiplication? Not 6. It has to be 5, right? If something divided by 6 equals 5 over... The only thing I know is 5. So x has to equal 5. And that's our answer. All right, so this time we had to go from area to scale, and that got us our side. All right, our final one says area of Zoid equals 16. Area of trap equals 25. Can someone tell me what my scale factor is then? Jamie? 4 over 5. So it's basically square root of 16 over square root of 25. So it equals 4 over 5. I'm not going to have time to quite finish this. But, so Zoid is my top. And trap is my bottom. So since we know our scale factor, you're gonna have to do this off to the side, but this is how you get your answer for A. We're looking for A, so that'd be 4 over A equals, we don't need to pack up, otherwise I'll just talk slower. It'd be 4 over A equals 4 over 5, so our A has to be 5. And our B is going to be 8 over B has to equal 4 over 5. So that'd be 4B over 40. So our B is going to equal 10. Whew, we got through everything. Awesome. And our homework. Our homework is on page 458. It's 1 through 16. I have terrible, terrible news to pass to you. Our test that's scheduled for Friday is going to have to be postponed until Monday. Then we get 2 review days, and because we have special assembly in the morning, and we have short classes, and I prefer to give you the full time to take the test. Special assembly? Senior assembly is Friday morning.
Is that the one with the wills?
Yeah.
Okay.
What are the whales?
Also,
There's
the
a
colleges
senior
each senior's going to,
They leave.
they
stuff.
like leave,
They
they're like,
bequeath?
like last year, like say like I blah blah, like leave this to blah blah, like
Oh, okay.
Like,
Like club presidency or something.
Alright, everyone, have a lovely, lovely day.
No, how do you not know anything about that? You don't know any of this. The next factor. Just the next factor? Yeah. That's so awkward to me.
They're both double of each other?
And I don't like her. You don't know
Well, then the double, well, A is
I have to talk to her.
oh, that these two are double, yes,
She was like,
because they have to have the same ratio, right? Yeah, so if I double, yeah, if this is double from here to here, this would have to double from there. So you could have used that back too. But yeah, we preserve that ratio, right?
This person.
you don't know her. You don't need to know.
Yeah.
I'm looking for that.
I'll let you.
Okay, it's going to be in that bathroom because it was dead. We didn't even use it.
This guy's so awkward to me. Oh my god, we're gonna be like, we're gonna get the basement. Or no?
Oh, okay.
Grabbed the wrong one.
Okay.
I want it because I want to fix it.
Okay.
It's in the back, like in the, post office in the gym?
Yeah.
Is that where it is?
Yeah, where the other one was charging? Because when we got it, we couldn't turn it on.
That other one.
Right.
I know.
There was one already in there, and we were trying to preemptively charge it, and so we plugged in the other one. So there was two in there charging.
Those don't work, those are just for the gym, those have nothing to do with outside.
Right, no, okay.
Okay.
Oh.
All right, let's start over, there were two in there.
No. There was only one in there.
Oh.
Okay, we got one, and it wouldn't turn on. It was completely dead or broken or whatever. So we couldn't turn it on,
You know where you
right?
got that one
I got it from Chris,
from? So I gotta talk to him.
about where he got it from.
Yes.
Yes, I don't know where he got it from, but I'm saying we had that one, it was dead, and it was like, I don't know, 20 minutes before the game, we were trying to fuss with it, trying to get it on. Completely dead, couldn't turn on or anything. And then we just plugged it in next to the other one that was already charging there, in the coach's area. Yep.
These controllers, there's two of them that are broken, there's only one that
Yeah,
works.
that's what-
It's outside of my office on the shelf next to the envelopes. That's the one that
Okay,
works.
is that one still there?
Oh, yeah.
Oh, okay.
Yeah, so when I came in this morning to fix the one, I'm losing it. And I don't know how somebody got in my office to grab that.
Yeah, that I don't know. I would assume Chris, because last time Chris got it from John, so.
Right, and I asked John, this line is up there.
Oh, okay.
Can't remember what happened Friday.
But we know where everything is now, right? At least?
Well, for now, until I fix the other ones, there's one that really works, and that's on the shelf right outside. I don't even know if you know where my office is down.
Yeah, I've seen it, yeah.
But that's the one. Hopefully, if I fix this other one,
We'll have two.
It'll be good to go.
Okay, okay.
So
But,
that other one should be in the coach's office.
yep, there was two plugged in when we left. It was still charging, so I just left it.
One is the bad one.
And
There
we-
should have been two others in that.
There weren't, there was just one charging, and I said ours next to
Somebody
it.
grab that one, because two that are just for basketball always stay there, because they only work in the school.
Right.
You're saying there was only one.
There was only one plugged in
And then
and
the other
charging.
one that didn't work is that.
Yeah, but you'll know because it's got the softball thing on, you know, the
That would
softball
be the
sleeve.
identifier.
Yep. So if there's two in there, we have
So
the
there
ones.
should be another one missing that belongs in there.
That I don't know about.
Shoulders going up.
That's the only thing yeah, it seems kind of like up in the air, kind of.
Not going down.
1, 2, 3.
Jim, I mean, really identify.
Yeah, but that's the only one I did. Okay.
Did you ask me to measure it? Mr. Fabian,
Yeah.
can we take a